Hi, this is Sean Power, and this is my week 1 presentation for my Patterns and Recognition course at Full Sail with Dr. Nardine. My first slide here in my presentation is an overview of the Ironman competition. It's a triathlon with a 2.4 mile swim, 112 mile bike ride, and a 26 mile run. There are competitions held for both men and women 18 and older from around the world. It's held in Hawaii each year, although it was not held in 2020 due to COVID. The World Championship is referred to simply as Kona, and the race typically begins at 7 a.m. with a cutoff time for the swim competition at 9:20 a.m., bike cutoff time at 5:30 p.m., and a run cutoff time at midnight. And if you don't make those cutoff times, then you are disqualified. So we were presented with an analytical problem. I have a friend, Marley, who has not competed in the Ironman World Championship, but she has competed in different Ironman 70.3 races and 5150 races. She has also run other marathons and competed in the Olympic pre-qualifiers. She wants to know what the correlations are between different athletes and the race details, as well as where the racers place. She wants to know what 5 variables are strongly correlated with where racers place. What is the likelihood that the fastest swimmer wins the Ironman? Same with the fastest biker and the fastest runner. And then what are the probabilities of the first person out of the water winning the race, and as well as the second and third person out of the water, as well as what is the probability of the first person off the bike winning the race, as well as the second and third person off of the bike. So the competition begins with the swim race. They get out of the water, they transition to the bike, and then they transition out of their biking gear into their running uniform and finish the race with a 26-mile run. So I'll be helping Marley to decide where she should focus a majority of her training time on. The research process began with aggregating the data here. In the attached Excel workbook, I have 5 worksheets titled 29 through 2015. This has data from tryrating.com. Excuse me, this data is actually from coachcox.com. And this includes it includes information on the top 12 athletes based on how the top 3 performed within each event or each of the splits, as well as the top 3 for the overall event. This gives me a larger sample size to run my correlation analysis. For my probability statistics that I present later on in the presentation, I used a smaller group of only those athletes that have placed 1, 2, or 3 in either the splits or the overall race. My attached workbook will be included with my deliverables for this presentation. First is the running analysis, and I started with the running analysis because Marley herself is a runner, so naturally she feels that maybe she might not need to train as hard in this specific event, but she wants to know nonetheless, is the fastest runner in the race always the winner? And this line plot here shows a regression line for those ranked over the course of 5 years as either 1, 2, or 3 in the race, the marathon portion of the race, and their overall ranking. So you can see their overall ranking is plotted in blue on the y-axis, and on the x-axis it shows their run ranking. So there is a correlation. There's a separate correlation that I ran, which was done by taking the correlation statistic in Excel for each of the 5 years and then averaging those correlations together. So I got an average correlation between the run time and the overall time of 0.866. I have an overall regression line they're plotted as 0.75 plus 0.8 times the run rank with a 73% fit. This specific analysis had a high p-value. That's likely just due to the sample size being too small. But if this was including more racers or more events, more annual events, then that would probably fall in line with less than a 5% p-value. The next analysis I performed was a swim analysis. It shows the same line fit plot with the swim rank on the x-axis and the overall rank on the y-axis. This regression line does follow a negative correlation that was performed by averaging the correlation for swim time and overall time over the course of 5 years, which yielded a negative 0.219 correlation. And the overall fit of this plot is 8.95 minus 0.6 times the swim rank, with a 27% fit on the regression line. The next analysis is the bike analysis, and this also is a positive correlation. The regression line shows the bike rank on the x-axis and the overall rank on the y-axis. The average correlation over the 5 years that I analyzed was 0.717, a positive correlation. Again, with the regression line fit at 1.86 plus 0.6 times the bike rank for a 42% fit of the regression line versus the sample. So next, I ran a probability analysis. I did this by breaking out my samples of 12 runners, 12 of the highest ranking runners in Marley's age group over the 5 years, and I took only those that, again, were ranked top 3 in the swim, bike, and run split, as well as their overall rank in the whole race. This is an example of how I sorted the table in order to look at just those who placed first in order to find these probabilities. So just for an example, the probability of the first person out of the water winning the race, if you look at the first 3 columns and you find 15 total cells, you can take the first place in the swim column A, and you can divide that by the 15 possible ranks. I apologize, I caught an error in my probability analysis here, so I updated that here, and I calculated actually a higher probability. So, for example, for the first person out of the water, you would actually just take that 1 in the swim rank column for 2015 and divide that by the 5 potential years, which would yield a 20% probability. And then the same for the person off of the bike. So in the bike column, for example, you see that you have 2 out of 5 years where the second person out of or off the bike actually went on to win the entire race, and that would yield a 40% probability, excuse me. And so next, just some other findings here. I actually pulled a list of the 2020 individuals that are ranked highest. They haven't raced in Kona, but they've raced, you can see in column B here, they've raced in a number of different Ironman races all over the world. I wanted to see if there was a correlation between how many Ironman races they raced in and where they're ranked here in these preliminary rankings. And there actually is a correlation. It is a positive correlation, but it's pretty small at only 0.29. The top 3 ranked in Marley's age group, I noticed, also have all ran in 2019 in Kona. So there might be a correlation, although I didn't run the correlation, there might be a correlation between running in Kona and ranking higher in these preliminary rankings. Okay, and my last slide here would just be my overall recommendations for Marley. Using the regression line analysis for the running event, because Marley is a runner, she knows that she places third amongst those preliminary stats here that I listed. Based on her time, she actually runs that 26 mile in about 3 hours. So I can take her ranking amongst those runners, and I can try to figure out where she fits on that overall ranking, and I can do that by running that calculation there. Overall, she would rank about 3.15 or somewhere between third and fourth place overall. And then using the probability analysis, we also know that, apologies, I had to make another correction based on the updated probabilities here, but there's a 20% chance of her winning the race if she's the first out of the water, and a 40% chance if she is second off the bike. So to me, this would suggest that she should try to maintain her race time in the marathon, and she should focus on really improving her swim time, trying to place first in the swim race, and then go on to try to catch her breath in the bike race. She doesn't need to place first in the bike race. However, if she places second, she can actually improve her chances of winning the race overall. And again, this would be dependent on her maintaining her place in the 26-mile run. So those are the recommendations overall. I hope that you enjoyed the presentation, and thank you for watching.